Hello everyone, this is my Phys102 project, and here I will be examining the frequency fluctuation of an LC circuit by demonstrating this metal detector. As we all know, metal detectors are used to find metals easily, and the answer to the question how do these devices actually work is the eddy currents. If one puts a metal somewhere near this coil, as you can see from the picture, some currents are created inside the metal. Some eddy currents are also called this way. And these currents creates a magnetic field opposing the magnetic field that is created by the coil itself. And so the opposing magnetic field is detected by this coil, and that causes the detector to detect metals, which can also seen by inside a metal detector, one can basically find an LC circuit, a basic LC circuit, which gives sustained oscillations, in theory. However, in real life, our systems are not ideal, basically, and hence there is always a resistance. And because of this resistance, we conclude with a damped oscillation. To prevent this, one can use transistors, which basically resets the LC circuit so that our damped oscillations becomes a sustained oscillation. And to see my experiment, let me continue in the lab. This is my metal detector circuit. Here I have a power supply adjusted to 4.5 volts. And here are the inductor and the oscilloscope. Here are my objects. The first one is a copper sheet. The second one is a plastic foam sheet. The last one are lead balls. This is my first trial with the copper sheet. Here I am slowly raising down the copper sheet and noting my data per each centimeters. And one can easily notice that the frequency of the LC circuit increasing due to eddy currents. This is my second trial with the same copper sheet. Here I am repeating the same experiment again. This is my third trial with the same copper sheet, and here I am repeating the same experiment again. Between the tries, there have been some differences. I believe this is because both the non-ideal environment, the oscilloscope delay between each centimeters, and me not putting the sheet exactly at the same position on the ruler. This time I am using a non-metal, a plastic foam sheet, and one can easily see that there is roughly no frequency change on the oscilloscope. This slight change might have been happening due to a non-ideal environment. Lastly, I am raising down the box containing 2 lead balls. Here again one can see the frequency change. However, this change is less than the copper sheet. I believe this is because of both the lead balls being in a cardboard box on a sponge and lead generating less eddy currents than copper.